So today we are going to start with Fortinet SD-WAN. Fortinet SD-WAN. So starting with the high-level overview of Fortinet SD-WAN and how Fortinet SD-WAN is different than Cisco SD-WAN solution, because they both are not similar. In fact, they both are not same. Fortinet is different than Cisco, of course. But let's first understand what is SD-WAN and how SD-WAN is different than legacy or traditional wide area network technology, because SD-WAN is basically software defined approach for or to manage wide area network WAN. So software defined approach is one of the software defined networking or SDN implementation for wide area network in general. But in Fortinet, even if let me quickly take one example first, and then I will explain in detail about this SD-WAN solution. What is SD-WAN? But quickly, let me take one example. So let's just assume you have a FortiGate firewall, only one location, and there are two transport or two different WAN link, like ISP1 link, ISP2 link, connecting internet. Only one site, only one location, two WAN links or two ISP internet links, both terminated to FortiGate firewall. And now you want to configure routing here based on performance SLA, service level agreement, means performance based routing. Also, you want to configure application based routing or application aware routing with intelligent load balancing, in fact, right, across these two different things. So in Fortinet is also known as SD-WAN, in fact. SD-WAN, however, yes, it can be defined as SD-WAN, but it's not only the implementation of like Fortinet SD-WAN, because it's something like performance-based routing only, because what we do, we create SD-WAN zone and we put both interfaces in that zone, like member interfaces. And then SD-WAN zone is used in SD-WAN rule, routing, policy, everywhere. So in very simple term, we define like this type of configuration as a SD-WAN, like Fortinet SD-WAN. But it's not all about SD-WAN solution. In fact, it is one of the uh, use case of Fortinet SD-WAN, that grouping multiple interfaces in single SD-WAN zone and then configuring performance SLA based routing, application aware routing, intelligent load balancing or load sharing across multiple WAN links is only one of the implementation. So let's take a big picture, in fact. And for that, let me quickly give you a recap or high-level overview of Cisco SD-WAN solution, so that we can compare both Fortinet and Cisco SD-WAN solution side by side. So let me quickly jump to the Cisco SD-WAN solution. Cisco SD-WAN solution. Because today I want to just give you a high-level overview of SD-WAN, and then in next session we'll just get deeper inside it. So in Cisco SD-WAN, first, like there is complete separation of, first, like SD-WAN here in Cisco or any other vendor is basically controller based solution, and controller can be deployed on-prem or maybe cloud. So controller base means with the help of controller, we manage like policies, routing, management, everything from controller. So if there are multiple sites like site 1, site 2, site 3, right? And each site there is a WAN device, WAN router. So if we want to configure routing, we want to create or configure policy, or even we want to manipulate path selection. So it's all done with the help of controller or centralized controller. Like, but in Cisco, in fact, it's not only a single controller. There are multiple controllers. So from controller, right, we manage and control like routing, path selection, even pushing like policy with the help of templates. Everything we done or we do from controllers, in fact. And controllers and WAN as devices, they need to have like connectivity using any transport, and transport can be anything like. So transport wise, like internet, broadband, 4G, 5G, LTE, any transport, any transport. So controllers and WAN edge devices, they like need to have a proper communication channel connectivity with any transport, in fact. And communication is also very secure, very secure. So for configuration, policy, route manipulation, everything like controllers are used. But for data plane traffic, if site 1 wants to communicate with site 3, so then there is no role of controller. Controller doesn't play any role here because traffic is never routed via controller. Then directly they talk to each other. They establish a IPsec tunnel, a secure channel using like multiple transport or one transport, depends like what type of configuration we have done, and then different sites, different locations communicate with each other in secure fashion. So for configuration management, yes, controllers are in picture, but for data plane, for user traffic, controllers do not play any important role here. Site to site reachability, site to site connectivity, yes, is done in fact. And very easily, like we like control topology also, whether we want full mesh, partial, hub and spoke. So in Cisco SD-WAN, with the help of policy, like we like control that, we change that topology in Cisco SD-WAN. So in case if we want full mesh topology, partial, hub and spoke, very easily like we do with the help of policy created from a centralized management server, right? So let's also understand like a little bit about different controllers used in Cisco. So one of the controller that is used in Cisco SD-WAN is known as vManage. vManage. So V stand for Viptela. So vManage is like management server. Management server. So for all management related operation, even logging, uh, creating templates, pushing configuration, vManage is used. So vManage is the uh, only controller like which provides GUI access and for all management operation. So it's a management plane controller. Another controller that we use in Cisco SD-WAN is vBond. So vBond is orchestration plane controller. So vBond is basically first point of contact for all WAN devices. So initially they first connect with the vBond, and vBond provide information about other controllers. So it's basically a glue, in fact, glue between other two controllers and WAN devices. And the third controller that is used in Cisco SD-WAN is known as uh, vSmart. So vSmart is basically control plane. control plane, management plane, and orchestration plane. There are three different controllers in Cisco. So vSmart is again an important controller because vSmart is basically control plane. Control plane means like a brain of all the devices, right? Means if site one router wants to exchange routing information with site two, say they do not exchange directly. No. First, routes are advertised to this vSmart controller and then from vSmart controller to another VNS router. So route exchange prefixes not exchange directly via vSmart controller. So again, vSmart controller plays important role here, but only in the route exchange. When it comes to data plane communication, again, vSmart will not be in picture. So for data plane, devices communicate directly with each other. For control plane, yes, vSmart is used. So in Cisco SD-WAN, there are three different controllers: vBond, vManage, and vSmart. Three different controllers. vManage is management server. vBond is your orchestration plane. We orchestrate everything from the vBond, and vSmart is control plane device, right? And VANS devices, like they are data plane devices. Even like they do maintain route table, right? They actually forward the traffic. So we cannot say like they are just a dumb terminal, like brainless. No, they do have brain. They do maintain routing table. Forwarding data are like is done by like site or managed devices only, but they are managed from vSmart in like context of routing or route exchange. So in Cisco SD-WAN, there are three controllers, and now it's up to you if you want to put them in your own data center. Yes, you can do that. If you want to put controllers in cloud or maybe Cisco managed controller, that is also possible. What you will have to ensure is reachability. The reachability of VANS devices with controllers. So controllers and managed devices, they should have proper IP reachability. Location doesn't matter. Placement of controllers doesn't matter. And another benefit of now let's talk about the benefit also. What are like SD-WAN benefits? So one like is controller-based solution. Controller-based solution, right? There is separation of data control and management plane. They all are like, and data plane and control plane are completely separated from each other, right? Controllers can be deployed on-prem or maybe cloud hosted. Now, apart from these three, like controller-based solution, separation of control data plane, controllers can be deployed on-prem or cloud hosted. So apart from these three, SD-WAN, first and the most important benefit is a transport independent solution. Transport independent. So what do I mean by transport independent? Transport independent means you can use any transport. You can use internet lease line circuit. Even if you have broadband internet, you can use that. If you have 4G or 5G connection, yes, that is also possible. Business broadband, even MPLS also. Because SD-WAN is a overlay solution. Underlay means like physical connectivity. No matter like for that, whether you have used broadband 4G, 5G, ILL, or LTE, right? So you can use any transport independent solution. And it is one of the main reason why like SD-WAN is so popular nowadays, because you are going to save money. Because if we have one site here, like maybe in US East region, another site in India, and the third site in India also, like let's say this is Delhi location. The third one is Bangalore. So in order to do WAN connectivity across these three sites, you don't have to have like expensive MPLS or lease circuit or IPLC circuit, international private lease circuit. They're really very, very expensive, one-time cost and also recurring charges. So what we can do, even we can use internet as the transport. Internet is available everywhere. So US East site is connected internet, Bangalore location, and Delhi location. So internet is transport here. But as we know, as we understand, internet is a public network, not very secure transport, right? So there is security risk. So in SD-WAN, what happens? On top of it, like IPsec tunnel, a secure tunnel is created, right? So even though transport is internet, public network, not any private lease circuit, but communication is done inside this encrypted tunnel, secure tunnel, IPsec tunnel. So security-wise, there is no compromise, right? Because of this IPsec tunnel, in fact. But this type of solution, like using internet as a transport and setting up IPsec side-to-side VPN, is not new concept. It's been like in the industry for so many years, right? So what's new in SD-WAN? Because this is like traditional approach, even like using internet and then on top of that setting up IPsec tunnel. So in SD-WAN, basically, uh, of course, like this approach is traditional. In fact, IPsec tunnel and all that is not very new concept. But in SD-WAN, what happens? Tunnel configuration done in very automated fashion. Even there are multiple sites, tunnels are automatically created. You don't have to do anything manually. Apart from that, even if there are multiple IPsec tunnel, so which transport should be preferred, right? For what application, that can also be easily done in SD-WAN solution. Even we can like set routing in such a way that for one set of application, one transport, one IPsec tunnel, for another set of application, another transport. We can also bring their like service level agreement. So routing, yes, like is very, very advanced, because in routing we include performance-based routing, performance based routing, also like links are also monitored, even like jitter, delay, right, packet loss measured, like, and automatically it's all done automatically with the protocol BFD, bidirectional forwarding detection protocol, application aware routing. So in SD-WAN solution, transport, we can use any transport. On top of that, IPsec tunnel is created. Tunnel is created automatically. In case of multiple transport, path selection can be done on the basis of like application. Even we can bring service level agreement there. We can configure routing based on jitter, delay, packet loss, right? And that's all done from controller. We don't have to do that individually on all the devices. No, in traditional approach, yes, configurations were done like locally on the devices. What we are doing, we are pushing configuration from a controller from here only. And a single template can be used to do like configuration for all the devices. That's very easily done. So it is one of the benefit, like that transport independent solution. So SD-WAN is a transport independent. That means it's not very expensive solution. It's not very expensive solution. And even apart from this transport independent, if I take another point here, okay. So another important point, as I mentioned, like application aware routing, AAR, with the help of performance SLA, performance-based routing, performance SLA. And there is another very good feature in most of the SD-WAN solution, and that is zero-touch provisioning. So in zero trust provisioning, what happens? Basically, known as ZTP. If you have a new location, a new site, and you want to add new location to existing SD-WAN fabric, right? A new site, in fact. And let us assume it's a very small site, and on site there is no network engineer who can do configuration, right? It's completely new site, maybe 20, 30, 40 people, and you do not want to send any engineer on site. But at the same time, you want this site one to be part of your existing SD-WAN solution, right? Maybe here, like there are controllers and different sites, all other sites already connected. So it's a new site, in fact, right? It's a new site. So zero trust provisioning means like let's say you have shipped a WAN router to the site. Here is the router WAN is device. So in zero trust provisioning, what happens? WAN is device at remote site is configured automatically, right? And how does that happen? So once like WAN is device is powered on, of course, like there should be a technician at that site who can do like physical connectivity, means Ethernet cable or LAN cable, network or switch, right? Also, power cable, and in that site location, of course, there would be a local DSCP server to provide IP configuration and all that. So when this router is powered on, so router or managed device obtains IP configuration automatically from local DSCP server, and already local router or managed router is configured with a URL like ztp.cisco.com, right? So, and with the DNS server, this URL is resolved to IP address, right? Because there is internet connectivity. So WAN is routed this way, connects our contact cloud-based ZTP server managed by Cisco, but we do some configuration there. We specify serial number of the managed device there, chassis number in customer organization profile, right? To the URL software.cisco.com, right? So once WAN is device router connects with GTP server using internet connection. So GTP server provides IP address of controller, and the first controller, orchestration plane device controller, and that controller is basically vBond, right? So this GTP server provides IP address of vBond, because WAN device is a brand new device, no idea about any controller or controller of that organization. And initial authentication or verification is done on the basis of serial number of the device, of this hardware device. So once like GTP server provides IP address of vBond server, so what WAN device then do connects with vBond server, right? vBond server can be in your premises or maybe in cloud. So now it connects with vBond server. And this vBond server means controller. vBond controller again does like initial authentication, checks like the serial number, because already serial number is already pre-populated. We mention here like the serial number of the WAN device that can be part of or that can join SD-WAN fabric. So after doing initial authentication, vBond provides now IP address of other two controllers, right? IP address of other two controllers. So now it provides IP address of other two controllers. And now WAN device then connects with vBond and vSmart controller, like once it has IP. And in vManage already there would be template configuration, binded with the serial number, right? So vManage now provides everything like site ID, system IP address, and even the configuration, because configuration is already here done, and even there is no manual approval required here because already serial number of the WAN edge device is listed in all three controllers, and that is used for initial authentication purpose. So this way, with the help of template and all the configuration, WAN edge device is automatically configured, and now this device would be part of the same SD-WAN and now can communicate with other sites now. So that's what zero trust provisioning is. ZTP is another very good benefit or solution of any SD-WAN solution. So SD-WAN means zero trust provisioning, means like uh, uh, configuring WAN edge device or remote site uh, automatically from the controller. So application-aware routing, performance-based routing, zero trust provisioning, controller-based solution. We manage entire life fabric from the controller. And another benefit of this SD-WAN solution is direct internet access, a DIA. DIA, direct internet access. So what is direct internet access? Internet access. So direct internet access means like in legacy or traditional wide area network scenario, if here like let's say is HQ or data center and a remote site or branch site. So traditional approach is like first like applications and other servers hosted here in like data center or HQ. So all the application servers hosted here, right? So generally, branch sites connect with the HQ, right? With expensive MPLS or P2P circuit, P2P circuit, right? So traffic from branch site is always routed to HQ or data center, right? Whether for internet bound traffic or even to access applications hosted in data center, where there is only one path. In fact, there is only one path. So no matter whether destination is internet or you want to access application hosted in data center itself, in both the scenario, in both the cases, traffic is always routed to data center or HQ location. This way, right? Yeah. Now, if internet bound traffic, not for any application, not for any server hosted in data center, then what happens? Rerouted from here, rerouted, and now it rerouted to where? Internet. So internet bound traffic then rerouted to internet like this, right? For local or application or server hosted in data center, then yes, traffic remains there. So in traditional environment, in fact, 70-80% traffic, like not internet bound traffic, most of the application servers, mail server, other servers hosted in like data center, right here, in fact. But nowadays, applications, most of the applications either already have been moved to cloud or in the process of like getting migrated, right? That means like applications not hosted here, servers are not in the data center or HQ. They are either in the somewhere in Azure cloud, maybe AWS cloud, Google cloud, right? So hosted in the cloud. Uh, that means nowadays 70 or 80% traffic means internet bound traffic. Internet bound traffic, right? This way. Because applications are not in the data center. So still sticking to traditional approach. Traditional approach means like traffic is first backhauled to HQ or data center, and then like maybe from here to internet. So offers will add latency, jitter, and unnecessary. You are paying a huge amount of money for maybe 1 gig or 10 gig of this MPLS or P2P circuit, right? So now in SD-WAN, like generally what we do, we configure this direct internet access. Direct internet access means internet bound traffic is automatically routed directly from the branch side to the internet. So instead of like first being routed to HQ data center, then internet, now directly internet, right? This way. DIA, a direct internet access, a local internet breakout directly to the internet. So of course it saves money because you don't need like very expensive and P2P or MPLS circuit. Even if you want like MPLS or P2P circuit, then you can have like a circuit like connected both sides, but not of 10 gig or 50 gig, because 70-80% traffic means like internet bound traffic. So hardly there are like 20-30% traffic bound to your data center or HQ. So you can go that way also, no problem whatsoever. And even we can replace this with internet, because even branch and HQ both connected with IP external. So why to go with this MPLS or P2P circuit? But a big challenge here in direct internet access, that security, right? Security means previously all traffic, whether internet bound traffic or traffic for your data center HQ, routed this way. And in data center at headquarters, like there was IPS, next generation firewall, maybe load balancer, and some other security devices here deployed here, right? So after proper inspection, traffic was getting routed to the internet. But now, since there is direct internet access, right? Direct internet access, traffic is not like back all to data center. So what about security then? There is no next generation firewall if at this side, it means no secure internet access. And nowadays, like firewall is also used to provide secure connection. Firewall doesn't not necessarily always means controlling traffic, right? What traffic should be allowed across different network segments. Firewall is also used to secure internet access, because a lot of threat prevention like malware, spyware, viruses can be prevented with the firewall. So it's one of the big challenges now in direct internet access. What will happen to the security? So either like this VANED device would have built-in security here, and some of the VANED devices, yes, uh, built-in with some security module, but it's still not capable. You cannot use in large or big size. In fact, very limited throughput and all that. So in Cisco SD-WAN solution, generally we prefer here to put a next generation firewall also at the side separately. In fact, even though like some WAN devices like built-in container there for zone-based firewalling and all that, but not capable of handling large amount of traffic. So best way to put a firewall, and at each site, in fact. So if you have 20 sites, so yes, all 20 sites should be protected, because you have configured now direct internet access. Or maybe you can go with some cloud-based security solutions like your G-Scaler, or maybe Cisco Umbrella, like secure access and secure edge solution, SASE solution, SASE. But yes, like you'll have to ensure security because Cisco WAN edge devices or SD-WAN is not mainly focusing on security, mainly like routing. In fact, as I mentioned, like some of models, some of the like devices, appliances, they have like built-in container for security, zone-based firewall and other, but not very much capable of like, and even they cannot be used for large sites. I mean, like where there are 200, 300, 500 users, so you cannot use that. Maybe very small site, 20, 30, 50 users. So yes, like no need of dedicated firewall. Otherwise, dedicated firewall, yes, either cloud-based or on-prem, will have to put that in place. Indirect internet access, DIA. So that's what like Cisco SD-WAN is all about, right? So Cisco SD-WAN means data and control plane both are separated. Controllers can be on-prem or maybe in cloud. SD-WAN is controller-based solution. SDN implementation, we manage entire network, be that routing, policy, configuration, everything from controller. And in Cisco SD-WAN, even like the brain control plane is also like part of controller, and that controller is known as vSmart controller. And good thing is like data plane traffic is never routed via controller. Controllers are only for the management plane in Cisco and also for the management plane and control plane, but not for the data plane. Data plane traffic always routed directly. And configuration wise, even IPsec tunnel and all that done automatically, right? So I hope you understand like basics of Cisco SD-WAN. A quick recap. If any questions so far, so yes, you can ask here, because now I will introduce Fortinet SD-WAN. What is Fortinet SD-WAN and how different Fortinet SD-WAN is with Cisco SD-WAN solution, because they both are not same. In fact, yes, some of functionalities same, but not all. And also let me because it's also building block. Let me also explain another term of Cisco, DMVPN, dynamic multi-point VPN, because very similar concept we have in Fortinet, R2 discovery VPN. Very similar, but ADVPN is like Fortinet proprietary solution, and DMVPN is Cisco proprietary solution. But they both are same. Functionality wise, almost they both are same. DM VPN and R2 Discovery VPN. R2 Discovery VPN is like Fortinet solution and using Fortinet SD-WAN, right? So let's first understand this DM VPN concept. So easily you will understand later on in like Fortinet SD-WAN, AD VPN. So in Cisco routers, like there is one like functionality known as dynamic multi-point VPN, DM VPN, dynamic multi-point VPN, right? So dynamic multi-point VPN or DM VPN basically is routing feature and uses NHRP, multi-point GRE tunnel, and also routing, and then IPsec for security, even is optional. So DMVPN is combination of like next to resolution protocol, multi-point GRE tunnel, routing, and IPsec tunnel. But what is DMVPN? And why do we use DMVPN, dynamic multi-point VPN? So let me take one example here. So here like you have one router, another router, maybe another router, three routers. Internet is the transport. All three routers connected with internet. Objective is to set up communication across all three sites, right? This site, network behind R1, network behind R2, and network behind R3. Let us assume this network is 10.1.0.0/16. R2 network is 10.2.0.0/16 and 10.3.0.0/16. So what you want to do here, you want to configure routing so that all three different sites locations communicate with each other, right? So yes, we can set up IPsec tunnel between R1 and R2, maybe R1 and R3. This way, right? It's a purely hub and spoke topology. So we can set up IPsec tunnel. But IPsec tunnel is configured, but topology is hub and spoke. So even in case if R2 wants to communicate with R3, then first like traffic will be sent to R1 and then from R1 to R3, means routing via hub router This one is hub, for example. And they both are spokes, right? So of course, like we'll add latency and even too much like resource utilization of the hub router R1. So best practice is like setting up full mesh topology, right? Full mesh topology, full mesh IPsec tunnel. But in case if there are 10, 20, 30 sites or locations, so configuring full mesh IPsec tunnel manually, literally very cumbersome, right? Manual configuration is very, very difficult because if there are 20 sites, so total there will be n minus 1 divided by 2 IPsec tunnels. Means 20 into 19 divided by 2, 190 IPsec tunnels. So it's not like very scalable solution. IPsec tunnel configuration manually in full mesh topology. So Cisco came with this solution, DM VPN solution, and only supported on Cisco routers, dynamic multi-point VPN. So what happens in DM VPN? Just high level overview I'm giving you, not very deep dive. So in DM VPN, first we set up multi-point GRE tunnel, right? GRE tunnel, and between spoke and hub, Then on top of that, we run routing protocol. In Cisco, like EIGRP is like recommended, but technically you can use any protocol, BGP, RIP, or any protocol. So routing protocol is used to route or send routing information of private networks like this. Here, like we have 10.1 and 10.3. So inside this GRE tunnel, routing protocol runs and routing protocol exchange routing information, right? 10.2 or something. And we also assign a private IP address to the tunnel interface. So after that, another protocol we use here, and that is next hop resolution protocol. Next hop resolution protocol, what it does, it maps public IP address with tunnel interface IP address, that is private IP address, right? Because IPs definitely would be required. So for that mapping registration, NHRP protocol is used. And then finally, what we do, we protect this tunnel, GRE tunnel, with IPsec. So, but what problem we are solving with this DM VPN? So let me quickly go to that point, right? So basically now, what happens now? Let me pick a different color. Okay. In NHRP or DM VPN phase, in fact, there is one concept here: shortcut message or redirect message. And what is that? So let us assume host behind R2 wants to communicate with another host behind R3. Means communication between R2 and R3, two spoke sides, right? Spoke 1 and spoke 2. Spoke 1 and spoke 2. So first packet, when reaches R1 hub router, so that is successfully routed, no issue. First packet like successfully routed to the R3. But now R1 understand there is better path to reach R3 because we all are in the same IP network or subnet, because tunnel interface IP, let's say you have assigned IP 192.168.1.2. So here like 192.168.1.3 and 192.168.1.1 and 3, right? Same range, in fact. Tunnel interface IP. I'm not talking about the physical interface IP. So R1 understand like we all are in the same network, in fact, right? So this is something like that in a switch, if there are 3 devices, and from here you want to communicate to this, so unnecessarily if like packet is first sent to this computer and then from here to here, so why not to send it directly? Because if they all are in the same net or in the same subnet, and that's what exactly happens here in Cisco, DM VPN solution. So when R1 like knows like there can be better path right? So first packet is yes routed, but immediately R1 send NHRP redirect message, a shortcut message that next time don't come to me, directly form a tunnel, IPsec tunnel, and do communication this way, right? Automatically on demand. And how does that happen? So there NHRP plays important role. NHRP maps tunnel interface IP with the physical interface IP, WAN port IP, public IP address. So once that is resolved, like ARP kind of thing. But ARP resolve layer 3 to layer 2, but here like mapping is done from layer 3 to layer 3, WAN IP to your tunnel interface IP. So once is done, then R1 and R3 they both negotiate tunnel, form tunnel, and then they start communicating with each other. So it's very much like full mesh topology on demand with minimum configuration, right? With minimum configuration and on demand. And that's what DMVPN solution is. DMVPN means on demand, full mesh tunnel with minimum configuration. With minimum configuration, right? Even a new site is added, let's say R4. So R4 will set up tunnel with R1 only, and then on demand, like other IPsec tunnels will be created directly. So that's what DMVPN solution is, dynamic multi-point VPN, right? So now we will bring all this knowledge to understand Fortinet SD-WAN solution. What solution Fortinet SD-WAN provides. So Fortinet SD-WAN is implemented in different ways, as I mentioned in the beginning. Even if there is only one side, there are two different ISP links, right? And there is only one FortiGate firewall. So simply like putting both interfaces in one zone, SD-WAN zone, and both are member interfaces, and then configuring routing, maybe on the basis of performance SLA, jitter, delay, intelligent routing, I mean, or application-based routing, that is also termed as SD-WAN, right, in Fortinet. Let's take a bigger picture. Bigger picture is, let's say you have multiple FortiGate firewalls, and you are looking for a similar solution like this Cisco SD-WAN solution kind of thing, means a centralized controller, centralized controller from where like we can push the configuration. So in FortiGate, yes, that is possible, and that centralized controller is FortiManager. And for proper log analytics, automation, and reporting, we also use FortiAnalyzer. So they both, like FortiManager and FortiAnalyzer in FortiGate, are basically you can say management and orchestration plane, right? Orchestration. So we can compare this management and orchestration with Cisco vManage and vBond solution, right? So in Fortinet also we have FortiManager and FortiAnalyzer. So management and orchestration plane. But what about the control plane? So here, like Cisco SD-WAN is very different than Fortinet. In Fortinet, FortiGate firewall running FortiOS, it has both data plane, control plane, plus security plane. Security plane is of course good, but like in Cisco SD-WAN, control plane is completely isolated, separated from the data plane. Whereas in Fortinet SD-WAN, both control and data plane, both are in same box, right? So same box, data plane and control plane, right? There is no like separate control plane or unified control plane as in Cisco, like we have vSmart, unified control plane. So, but in Cisco Fortinet SD-WAN, control and data plane both are in the same box, in the same device. There is no separation of data and control plane. For management operation, yes, we have like management and orchestration plane, but not mandatory even. Let's say you are okay with like doing configuration locally on all the devices, you can do that. You can do that. You don't need any controller. But for large number of sites, definitely you need a centralized orchestration and management plane. Transport wise, yes, in Fortinet also is a transport independent solution. So you can use any transport. You can use any transport, right? So you can use any transport. You can use any transport here, be that internet, 4G, 5G, whatever transport you want to use, very similar to Cisco SD-WAN. So it's a transport independent. For IPsec or something, like if like let's say you have done similar configuration like hub site and spoke sites. So initially you started with hub and spoke, and then you want on demand full mesh connectivity. Yes, that is possible also with the AD VPN solution. AD VPN solution, not DM VPN, but here like we use AD VPN. So even if there are uh, 3 or 4 sites, one is like hub site, and there are 3 spokes, like this way, like IPsec tunnel is created, and you want like spoke 1 and spoke 2, spoke 3 to communicate directly, not via hub site, like this way. So yes, like done without any configuration, additional configuration, because here also we have AD VPN. So with that, like with shortcut message, even spoke to spoke IPsec channel is created automatically. So that type of solution, yes, we have in Fortinet also. For zero test provisioning in Fortinet. So for that, like Forti Cloud, Forti Cloud is basically cloud-based, portal-based, basically like management solution. So when we buy FortiGate devices, then we register FortiGate firewall devices to support portal of FortiGate, right? Support.fortigate or fortinet.com. So we go there, we create account, we register devices, we create profile, FortiManager IP also. And this like complete is known as FortiCare, because like device registration and everything is done from here. And also sometimes we use another term, FortiDeploy, right? So what happens in zero test provisioning in Fortinet solution? So it's a branch side, and here let's say you have a FortiGate firewall, and you want like this device to be configured automatically. So what happens? It already like you'll have to put the serial number of FortiGate firewall in your account. In fact, in this Forti Cloud portal, is a cloud-based portal managed by FortiGate, of course. So device first like hits like this Forti cloud like based portal, and from there, uh, FortiGate firewall gets IP address of FortiManager of your organization. And now again, FortiManager can be either in cloud, in on-prem, any site, very much like in Cisco, like we have both the options, on-prem or cloud. In FortiGate also, even private cloud, public cloud, on-prem, you can put FortiManager anywhere. So now FortiGate firewall obtains IP address of FortiManager. And once like it is obtained, then directly it connects with FortiManager. This FortiManager is like your orchestration and management plane, and can be in on-prem or anywhere. So connects here. And generally, there are multiple options here. Like one of the option is like doing manual authorization. That means when FortiGate firewall connects with FortiManager, so we just see that serial number in the list, and then we do manual authorization. Okay, you are authorized to join. Even we can run like some Ansible script continuously that to auto approve. Even like best option is like whitelisting the device, means like best option is like going this way. In FortiManager, just already create like template and bind that template with the serial number of FortiGate firewall. We create different templates here like system templates, IPsec, and other templates. And a serial number is also binded with the template. So whenever FortiGate firewall connects with the FortiManager, and FortiGate manager has already configuration here binded with the serial number, and serial number is like the first point of authentication. And so this way, like configuration is automatically pushed to FortiGate firewall. So GTP is very similar to what do you call it in Cisco. Like we have gtp.cisco.com cloud-based GTP server. There also we create a profile. We put the device serial number to organization profile, and WAN is device first connect with the GTP. From there, obtains IP address of vBond. vBond is orchestration plane. After doing initial authentication, then configuration is pushed by the vManager. Same happening here, but here like FortiManager is doing everything. FortiManager is even the point of contact is FortiManager here, and FortiManager IP is provided by FortiCloud, known as FortiDeploy. So in FortiGate also we can do this GTP. So GTP is very similar to Cisco, in fact, zero touch provisioning. And what other benefits we have in FortiGate? So in FortiGate, let's say you are doing exactly the same thing, direct internet access. This is a FortiGate firewall. So FortiGate is basically a next generation firewall. SD-WAN is additional feature, right? So here, like security wise, no problem whatsoever. You don't have to buy additional firewall because the same device is doing both, like capable of doing next generation firewalling and along with the SD-WAN. Whereas in Cisco or other solutions, mainly they are focusing on SD-WAN or routing, not of security. But in Fortinet, security is built in. So even in case if we have configured direct internet access, not like backhaul to data center and then internet, no problem in FortiGate, because FortiGate is like a next generation firewall. So you can create security rule policy to inspect traffic, to control traffic, very much as we do with the firewall, because FortiGate is primarily a next generation firewall, and then this one is additional service SD-WAN. Plus the last in Fortinet, no separate license for SD-WAN. No separate license for SD-WAN. So definitely customers like this feature, that if you want to configure SD-WAN in FortiGate, already your FortiGate firewall has license. You don't have to buy any separate license for SD-WAN. You are free to use SD-WAN feature capability in Fortinet. In other solutions, even in Palo Alto, for SD-WAN, like there is separate license. Separate license is required. Without separate license, you cannot configure SD-WAN. In Fortinet, is absolutely free, absolutely free. So there are some like benefits. There are some limitations or drawbacks also in Fortinet. Like benefits like absolutely free, like you don't have to pay. Firewall is built in, like in Fortinet, but control and data plane is still in the same box. So we cannot compare with Cisco SD-WAN solution. In Cisco SD-WAN, data and control plane are completely isolated. In Fortinet, they both are in the same box still, right? But Fortinet provides a lot of flexibility, because even if you have a single site, single firewall, you want to make use of SD-WAN rule, application aware routing and all that without FortiManager, yes, you can do that even, right? You don't have FortiManager, you don't have multiple sites, only one firewall. But you want to create SD-WAN rule. You want to configure performance-based routing, application-based routing, because you have 2 or 3 internet links. Yes, that is also possible. You have large number of sites. You want like to bring centralized management, logging, orchestration, AD VPN and all that. Yes, that is also possible. So there are different implementation scenarios, deployment scenarios in Fortinet are supported, easy to configure, but Cisco is different, of course. So any questions so far? Because today objective is just to give you high level overview of SD-WAN solution in general. I mean, like what is SD-WAN? Next class will start properly, and I will keep today's session short, in fact. So, but any questions so far, or any point if you want to discuss or add on to the discussion? So yes, you can do that.
No, I'm good.
All good.
Okay. And I hope you all also understand differences between both SD-WAN solution, right? So one difference, as I mentioned, Cisco data and control plane are separated. In Fortinet, no, both are in the same device. In Cisco SD-WAN, you will have to have uh, controllers like your vBond and vSmart and vMan. It's a very large scale deployment scenario. Fortinet can be used in large scale, small, single site, anywhere. Only one or two feature of SD-WAN you want to use, yes, you can use that. Simply you want to club, you want to put like multiple interfaces in one zone, and you want to use that zone in your policy, that is also possible. A lot of use cases or deployment scenario for very small customer, large enterprise networks, plus not very expensive because there is no separate license for this Fortinet SD-WAN solution. So all in one, like, is a good solution. Like, I mean, like this Fortinet SD-WAN. All right then. So I will end up today's session here. I have some work, so I'm keeping today's session short. And next class will like start only like Fortinet SD-WAN, of course, step by step. First, like traditional routing, and then SD-WAN routing, SD-WAN rule, AD VPN. We'll understand AD VPN. Forti Manager will also understand here. Forti Manager, integration of firewall with the Forti Manager. So we'll see all this feature.
Okay, sir.
Okay.
So next class will be on Thursday or when? Friday.